This is not even suspiciously, this is quite good. The special feature is the kinetic taskbar. I've never in my life seen this. Today we're going to be looking at a very interesting and somewhat controversial new release from iQuest Lab, dubbed Coder-V1 40B. Now, there are a few different models that have come out under this IQuest-Coder family of models. For today's video, we're specifically going to be focusing on the two largest available ones right here, Coder-V1 40B Instruct and Coder-V1 40B Loop Instruct, which is kind of where the secret sauce or the very interesting technical one lives. Now, before we get into this, I do want to mention a few things. One, feel free to subscribe. Two, I did enable channel memberships for less than 10 cents a day. You can support a YouTuber like me, which I will be begrudgingly mentioning in most videos. And three, this model is controversial because the benchmark they showed is almost so far-fetched looking that it is kind of unbelievable in sort of a way, where we see right here that this 40 billion parameter model is hypothetically outperforming closed source state-of-the-art models from various different labs, as well as open source models from highly regarded labs like Kimi and Quen. So initially, upon first glance, when one looks at this benchmark chart, they're going to kind of assume this is benchmaxed, which is the notion that the model is trained specifically to perform well on these things. The downside of that is it does not generalize well on unseen tests or things that it's not specifically trained to do, whereas the rest of these models would maintain their strength in these specific random tests. So with that out of the way, I'm very interested in testing this because I personally have not played with it at all. So I don't know if it's benchmaxed or maybe it is like the next DeepSeek moment, as some people have been kind of mentioning it as. Now, there are a few other things I'd like to quickly just go over in terms of technical considerations when we run these tests, but I do have the model actually running right here in a chat UI. I am hosting it on a run pod because I did not want to just get some random quantization of this, especially when testing a model like this that has these kind of potent looking benchmarks. I want to at least do my due diligence in ensuring that I test it in the most capable manner. In addition to that, I did also make sure these sampling parameters were the suggested ones that we see right here in the Hugging Face model card. So we'll take a quick look at some of the interesting things here, or at least further reading for those interested in the technical specifics of this, and then we'll just jump in and start testing it. The first thing I want to bring up is they do mention a thinking variant of this model as well, which currently does not exist on Hugging Face. So at the time of this recording, that thinking variant is not actually out, at least in a way that I can see it. Two, in the benchmarks here, and kind of annoyingly, it's not specifically listed what model produced these benchmarks unless you look in the technical report, but it's not listed here in the Hugging Face model card or anything, which I guess is kind of nitpicking, but it would be nice to see. So in these benchmarks, for every single one of these except Live Code Bench V6, the Loop Instruct model performed this, which is coincidentally the one that we're actually able to test right here, so that is very good. The only one that was done without a model that we can actually test is the Live Code Bench V6, which was done with the Loop Thinking model. Now, with this model, the whole loop isn't just a random thing that's placed in its name. It is directly referential to the architectural improvement or findings that have hypothetically led to this impressive performance. So if we scroll down here, and again, this is totally out of scope, but I do just want to list this almost as a suggested reading kind of thing. The interesting thing right here is in section 2.1. So for anyone interested, you could even paste this into an LLM, this section right here, maybe the whole paper as a PDF as well, as it's not very long, and just say metaphorically explain this to me in a way that I can understand. But I think basically the gist of it is, so from what we see right here, during the second iteration, down here to where two attention outputs are combined using a learned gating mechanism, this is kind of where it becomes the special sauce, is this second iteration as well as the two attention outputs being combined are not things that would have existed in a different standard type of model, even such as the non-loop 40B model. Sorry, I got distracted for a second. You know, with the MOEs, like a Quen 330B-A3B, they have listed here the loop model as a 40B-A80B. Where did I see that? I've seen it. I thought I was losing my mind. No, it's just in their announcement blog post. So the loop model is listed here as a 40B-A80B, which is very perplexing, but that coupled with looking at that section 2.1 in the research paper should lend some insight into why that's done and make it become a little more understandable to say. Now, they do show some results right here, which are kind of decent, but you know that we like to jump in and just do our own tests. I will say this solar system one looks very good, and this is something that if we saw a year ago, seeing a 40 billion parameter model was able to do this, one would be quite impressed. So I am going to be testing this model in the same way that I would test any of these other models that are listed here in these benchmark charts, which is by giving them our full set of prompts that are designed to really test them. So whether or not this is actually benchmaxed or it's like some super savant model, we're about to find out. So let's do it. So let's just do our browser-based operating system test, the historic test. And for those interested in how much VRAM this is using, we're running it on an NVIDIA H200, and it's using around 77 gigs of video RAM. Now, we're also going to test the non-loop model as well, at least on a few of our beginning prompts, just to test the difference in both response quality, but also speed, as we will notice that this model may be a little slower than the non-looped model. All right, let's take a peek at our browser OS. We do have a start menu, which does open with some app names, so okay. There's no right click and there's no clock. I'm not even going to sugarcoat it. This is a bad result comparatively to what one would expect based on these benchmarks. Now, I did not run the browser OS v2 prompt, which has more fine-grained detail and guiding them in specific what we want to see. So I will do that now, but first and foremost, first impressions, I am a little weary of, So we're going to try this one more time with the browser operating system v2 prompt. So, okay, I'm happy to see this because instead of before where it started out by saying this is quite a complex task, but here's what I can give you, which is just like an immediate red flag for the result quality. Okay, well, this seems hypothetically like it may be kind of interesting. And of course, this specific prompt is designed, it has to include 5 different apps, the ability to change wallpaper, and 2 of the apps must be games, as well as the special feature, which we did just see briefly mentioned there. So if this does actually put out what is being hypothesized here, I will be very impressed. All right, we hit the maximum output length. Now, the reason I did set the max new tokens to 8192 is because that's what they have right here. So just for justification why I set it like that, I think I'm going to give it the entire response that it had generated and say this response is incomplete, finish it. We'll test its ability to iterate upon partially generated code. We can see it is now attempting to continue the script from where it left off, which is good to see, to the point where it did just start from right above there, which is better. If it had just continued from right here, it would have been a little more difficult to understand visually where it's picking up from, but this is good to see. So I will be interested in seeing how it handles this. While this is not ideal, we can almost think of this as a separate test within a test, because not only is it having to generate this browser OS result, but it's now having to actually see all of that result first and then continue where it left off, which I would think hypothetically would lend itself to a strength of this potential loop mechanism. So this could be interesting. All right, so it did actually at least finish the script, and it took a very long time, so I wasn't watching it the entire time, but throughout some of it, I would glance at it, and it did seem like it did an alright job. So, all right, I pasted the rest of the code in, and basically okay, so far, I'm definitely significantly more impressed than I was with this. Nebula OS, I've seen that many times before, which is curious, but okay, we do have a right-click menu. This is suspiciously good. And I don't say that to be like, hey, I'm popular, they knew my benchmark. This is a fairly well-known test at this point, but this is version 2 of it. And regardless of that, it generated a partially complete script because I kind of incompetently set the maximum output length to something too low. And I pasted that script back to it and said, finish this from where it left off. And it generated the rest of the script while looking at the previous generation, not even in the same chat window. So this is actually, this is suspiciously, not even suspiciously, this is quite good. Now, I'm not ready to be like, oh my God, this is the new DeepSeek. But I will say that I am very curious to test more with this. Okay, we have the date. That is the correct time. And then we have that IPC thing, which is the special feature it had implemented, which was like inter-app communication, which is kind of cool. So that's a quantum chat thing. Let's just go through most of it right now. Okay, we have text editor. Looks good. I do like the kind of cyber aesthetic that it ascribed to this text editor. I'm cool with that. The full screen is not working. Neither is the minimize, but close does work. So I suppose I'm okay with that. Let's check the paint application. Interesting. Why does that? I don't intend to draw things like. I was gonna say before I got distracted by. So my cursor's here, but it's drawing it like off sides, which is, you know, that's all right. Can we change to any color? Yeah, we can. All right. Okay, I don't know if that the color change reflected. That's okay. It's good enough. Let's try Minesweeper. All right. Not being able to make these bigger may become somewhat of an issue, but... All right, I don't know. I'm not an expert at this game, but I'm not 100% sure that this is working properly, so someone can maybe mention that. And finally, we have settings. Okay, we can change wallpaper, dark. We have uptime as well, but the uptime seems to have started from when I opened the settings app, so this would be a setting-specific uptime. Let's just try upload image. All right, here's a screenshot of a bamboo slicer from our previous video. All right, so it set that to the background. That's that's pretty good. All right, we didn't check this. I need to change that back, don't I? Because this is going to be distracting. All right, I changed to a more suitable background. Now let's try this special feature, which was quantum chat. I don't exactly know what the purpose of this was. I think it was like something apps can speak to each other, but I don't know. Yeah, I don't really know what this does. So that's going to be, ooh, that has nice transparency to it. This was a very, very, very impressive result. I do believe this is significantly better than any comparably sized model would have been able to do. Even like, I don't know, we need to test it more before I definitively say anything. Now, as a head-to-head comparison, we're going to actually run the same exact prompt, but using the non-loop model. So in this case, we're just going to be using this Coder 40B instruct model right here, as opposed to the one we previously just did, which was the loop model, because I want to see the direct head-to-head difference in both code quality and speed. So as we reload this, we're going to see we're in a different UI right now. It's just using the non-loop model. And I'm going to paste the prompt in. I did change the max output length as well. And we're going to see a couple of things that I do want to make note of. First and foremost, we see the speed here is significantly faster. Now, that is just kind of a function of this not having that looping mechanism as well. But I would also like to showcase something interesting here, which is that this is using pretty much the same amount of VRAM. So both sitting around 75 to 80 gigs of video RAM when being used. And this kind of highlights some of the uniqueness of this model. So I will be very interested to see how the quality of this result is different compared to the one we got previously, which was extremely impressive. But again, I'm going to wait and hold off on my judgment until we test some new and perhaps novel things with this. All right, so here is the non-loop version browser OS. Okay, it's somewhat similar in the color. Well, we can't factor in the desktop because I changed that, but the color scheme is similar. There is no right-click menu. We do have a file manager, though. That's kind of nice to see. Change wallpaper. Let's see if we can... Okay, we can, but I'm going to change it back to the sob. Do these fake files exist? Nope, they're just kind of listed there, but that's okay. Can we resize these windows? We cannot, but we can drag them around. Next up, we have, oh, our Ether terminal. Nice. Help. Okay. Ooh, Snake. I can launch Snake from the terminal. All right. Let's see what's up. Moving on, we have a Snake game, which we're going to just, like, yeah, that's like, I can't say that, never mind. And then we have an info thing. The special feature is the kinetic taskbar. Try pushing the icons on the taskbar. Does that mean hover effects or... What? That's just so weird. Did that get like accidentally placed in this Snake game as well? Is that a kinetic snake? I've never in my life seen this. Now, some may say there's a reason for that. And, I would, it's just like, wow, that's oddly odd. Unique, definitely. Definitely unique. All right, I'm just restarting now the web UI using the loop variation of this model, since that's really the one I'd like to prioritize my testing on, although that kinetic taskbar was definitely something I've never in my life seen. Now I think we'll just try a 3D printer sim. All right, so our 3D printer simulation result is finished. Now, I do find it interesting looking through the code. In some of the code comments here, it's almost like asking itself questions and then answering them. All right, so here's our 3D printer simulation. This is looking more like it's frustrating because there will be a probably fairly simple issue here for this to resolve, such as a syntax error like this. Now, I want to give it the chance to fix this, especially being that it's open source. That's always kind of like, okay, you get an extra chance. It's just so frustrating because it takes very, very long time to generate. So while frustrating for my patience, Claude messed up this vibe-coded chat interface in terms of the chat history, so trying to send it that error message and saying fix the script just glitched it out. Therefore, we lost the conversation history. I'm going to just try the 3D printer simulation again one more time with proper logic here in this web UI if we need to send a follow-up message so it does not crash, just in case. Obviously, this would be an initial failed result, but at this point, this is pure curiosity. I want to really test this model and see how it does. Now, because this is taking such a long time, I've gone ahead and just rented another pod to run another separate instance of this so that we can run tests simultaneously, because I've been filming this for longer than I had anticipated. It is possible again that this will fail on first time, but hopefully if it does, we can actually try to fix the result. Okay, well, we're not going to need to, which is cool. All right, let's start our print complete. Okay, well, it does not necessarily work, but, oh, okay. I do see a triangle there. It's just part of the issue is that it's not actually possible to move the camera view in any way here, which is messing it up because I do see a small blue triangle under this nozzle. So if we try again, we see that I think it's drawing something, but we can't really see it except for with the triangle example. So overall, this is an okay result. Definitely not going to blow away any of the other things this is benchmarked against, but the fact that a 40 billion parameter model actually did this, I suppose, is acceptable. I'd now like to try a Python 3D first-person shooter result, being that I want to just try it at least with one other language. I don't know if I'm going to do C++ here because the time this takes, and then maybe we will, I don't know. All right, we do have our completed Python 3D first-person shooter done. Interestingly, it did not opt to use Ursina, which a lot of the models do, so this may be interesting because it just used Pygame. All right, let's take a look at our Python first-person shooter. Okay, it did start and open without any issues, which is definitely a good first try. Start, press space, exit, press escape. All right. Okay, I don't know. WASD, move. I am pressing WASD. Oh, that's me. I am the blue. Now, again, I'm a bit, okay, the minimap works. Here's the problem. I said 3D, and this is quite 2D. So while it does work, I'm not very impressed because this is something that is kind of 2D. All right, well, it did work, but it did not properly adhere to the prompt. I'm now giving it a 3D web racing game simulator, so this is something I gave to GLM and Minimax in my recent testing video, which are decently larger models, so I will be interested to see how this does, and if it does not fall into the trap where it did in the Python test where it just made it 2D even though it said it would be 3D. Alright, our 3D racing game result has completed, so let's test it. I swear if this did just another 2D, I'm going to be mad. Okay. All right, so it doesn't work, but at the same time, it did draw some fairly interesting 3D elements here for the map. So we don't have any real functionality, which is quite frustrating, but the map is actually not bad. So let's go into the developer tools here and see if we have, oh, wow. Okay, so we do definitely have a large amount of errors. I really don't think this is going to be a proper result here where I'm just telling it to fix it. Being that it's so slow that I don't really think it will I don't know. My patience is running out, to be honest with you. Now, very frustratingly, I was running another instance of this, and it was generating code, and then all of a sudden it just said error, and the entire generation disappeared. So I suppose we can try another test with this. So I'm going to try a modern aesthetic Steve's PC repair website contained in a single script. Okay, so it's going to give us some glass morphism and neon accents, as well as some JS for smooth interactions. I'm looking forward to this. All right, our Steve's PC repair website has been completed. We did denote a beautiful and modern experience. Damn, that's actually, that's not bad. So this is nice. Again, though, like a result like this is something GLM432B could have popped out. So keep that in mind when judging this, because remember, the whole point of this video is to see if those benchmarks are like have any legitimacy. But I will say this is not a bad looking website. It is quite modern, and I do like the weird color effect in the background. So let's scroll down and see, okay, what I do. I guess saying I there does work, being that it is Steve. That's a nice hover effect on these, and I do have to say the logos it used to actually associate with each one of these specific topics do look nice. The builds and upgrades, okay, I guess a shopping cart does kind of make sense for that. So not bad. Software optimization, and the hover effect that comes on top of it has a nice like modern tech aesthetic, so that's not bad. Let's see, ready to get your PC fixed. Oh, okay. Well, that's fairly simple. We do have a light footer, but it is kind of denoted by this block here to separate the main content from the footer. And then we have a fake email address, which isn't bad at all. From liquid damage to slow software. Okay, well, this was fairly light, but overall not a bad looking result. I'm like almost ready to give up on this test video, as I've been doing this for hours and the model's just so slow. I'm using a B200 right here, and then this other one is an H200. For some reason, the B200, you can see it's quite slow right here. So for now, I'm just trying the flight simulator game, and I'm just going to see what comes of this, because I am genuinely interested in this, which is why I'm putting so much darn effort into testing it, because those benchmarks are so outlandish that I really wanted to give folks like an actual look at testing the non-quantized version of this model, which I'm now coming to regret. I should have just pulled the GGUF and not cared and been like, hey, this is what it is. All right, our 3D plane result, the 3D flight combat simulator, has concluded, so I'm very interested to see this. Okay, we have aerial assault. Select your aircraft. They do have hover effects. All right, this is interesting. So some of the ammunition's not working, and this is, I suppose, 3D because the shapes are 3D. It's just not necessarily what I had in mind, and it doesn't seem like some of the arrow keys work. So basically I can only go forward and backward. I believe that is an enemy there, but sadly there is no ammunition that is being shown. Oh, okay, there's another enemy, and the star background is certainly interesting. So if we do look at the developer tools, all right, there's nothing per se wrong. It's just, I wonder, oh, okay, so maybe the ammunition didn't work, but if we hit an enemy, they will die. And then, okay, they're almost popping on us like balloons. Very interesting result. All right, let's try a different aircraft. So, okay, so I think they're probably all just the same shape, but different colors. Let me guess, green or yellow. Oh, I was completely wrong. It's kind of white. Okay, overall, it's a functional result. It's just not necessarily what one would have in mind compared to a model this is benchmarked against, which would produce a more lucid result. To give a direct example, I suppose, if we go to my GameBench Ultimate Play website right here, let's just look at, okay, not the Grok one. Let's look at like a GPT 5.1 Pro. So, all right, I suppose this isn't necessarily the most fair comparison because these are all like heavy duty models, but I would expect maybe something not quite at this level, but a little more similar to this than what we saw. Although I guess now looking at this, the perhaps bones of what we got are definitely kind of there. It's just, I don't know. You can make your own judgment. I guess I'll just try like a roleplay test. Okay, well, that's good. No, okay. It was all right. I don't quite know what to say, but I wanted to test it. All right, is my final result here done? No, it's not. All right, we have our 3D first-person shooter result. So, okay, it does run without any errors, which is always a good first step. Let's go ahead and see. Okay, spacebar or click. There's really nothing to do, sadly, because exit works, but start game doesn't. So I guess that's going to conclude this test video, which truthfully did take a very long time. If you noticed the clock in when I first started filming this, and now it's been quite a while. But a model like this is quite interesting because most times when we see a benchmark chart like this for a model that is so significantly small compared to the things it's being benchmarked against, it is kind of suspicious. So I wanted to go ahead and really test this because one day we'll probably see something like this and it'll be the real deal and everyone will be like, oh my god, this is like a new paradigm. But right now I don't know that that is the case. I'm going to say for a dense 40 billion parameter model, I do believe it's actually not bad at coding. It seems to have some level of spice or uniqueness, if you will. And part of the reason I say that is it did manage to do like some 3D graphics and things like that. The Steve's PC repair was decent looking, but again, this is something that like GLM 432B could do and it wasn't a crazy deal. This was actually something, although this Neon Highway 3D racing game did not work, it actually, had it worked, it would have been relatively impressive. I think for a model of this size to actually do a 3D map with some nice effects and things like this, I may be mistaken, but I think this actually shows some level of potential, if you will. In terms of our 3D printer test, our first result, as we may recall, which was a while ago, sadly did not show anything. The second try did, and again, this was not with having it vibe code fix this, it was just with having it generate a new one because Claude messed up the memory feature in the vibe coded web chat UI, and it did kind of do something, and again, this is like a more difficult test than just like a Steve's PC repair, so again, this shows at least some level of understanding, I suppose could be said. We also had, this was very interesting. So if you recall, we did two OSs, one with the loop version and one with the non-loop version. So the one that was done with the loop version here, the Browser OS Test V2, was a very good result, very, very impressive, which is so odd because when I just did the simple original Browser OS test of using HTML, JS, and CSS generate a Browser OS, it sucked. This was a terrible, embarrassing result, but when we gave it the full V2 result, it really went all out, and that was a significantly increased prompt detail-wise, so that may be responsible for this as well, but this was a really nice result. But again, if this thing is just totally benchmaxed, there is a chance that it is benchmaxed as well to perform well in this specific test, so one can't be 100% sure, but the result even, I mean, this kinetic taskbar from the non-looped thinking version was quite interesting, so I would say the overall takeaway from this is, do I buy that this is destroying like Sonnet 4.5 and GPT-5.1? No, but it's actually not horrible, and sometimes you see something like this and you think the model is going to be like good at one specific prompt that it's been trained on and everything else would just suck. It seems to generalize decently to other kind of coding tasks. So I think it will be interesting to see if they do release the thinking version. And then I have not tested any of these smaller variants. So the 7B may actually be kind of neat to see how well a dense 7 billion parameter model can pull off some coding stuff. So regardless of that, there was a lot of buzz around this and I wanted to do a proper test of it. I saw some tests of it, but no one really like tested it. And now I see it's kind of was a pain to get set up and using RunPod and making sure that everything was set up. And then the model ran incredibly slowly, even on the hardware that I'd rented, which was rather pricey. So it was understandable why I saw a lot of lackluster tests on it, but I wanted to do something kind of familiar. So with that, that is going to wrap up this video. If you have any questions, please feel free to leave them in the comments once you've subscribed and joined as a channel member for less than 10 cents a day in most months. And thanks for watching.